Welcome to the SIDRA software video for the Missouri Department of Transportation. This video corresponds with the MoDOT Engineering Policy Guide, EPG 905.3.5.2.2. Key takeaways from this module include when to use SIDRA, typical SIDRA parameters to be aware of, typical measures of effectiveness, or MOEs, for a roundabout, SIDRA compared to other tools, and common application situations. Let's begin with an introduction to SIDRA.
SIDRA stands for Signalized and Unsignalized Intersection Design and Research Aid. SIDRA is a deterministic tool. This tool category uses static formulas to quickly calculate measures of effectiveness, MOEs. SIDRA can be used to analyze a variety of intersection types, but in the United States, SIDRA is primarily used to analyze roundabout operations because of its ability to model the effects of gap acceptance, including roundabout geometry, on roundabout levels of service, LOS. Roundabout analysis is a strength of the SIDRA analysis tool.
Let's discuss typical parameters. Please be aware that there are a select few key SIDRA parameters covered in this module. For more detailed information on SIDRA parameters, please refer to MoDOT EPG 905.3.5.2.2. SIDRA software uses two roundabout capacity models: the U.S. Highway Capacity Manual, HCM model, and the SIDRA Standard Model. The U.S. HCM Roundabout Capacity Model is based on the calibration of most model parameters using HCM default values as applicable. The SIDRA Standard Roundabout Capacity Model is based off the HCM, but provides additional analysis for the following: the effect of roundabout geometry parameters, like roundabout size, circulating road width, entry radius, and angle, on capacity, critical gap and follow-up headway reduction with increasing demand flows, and the effects of vehicle arrivals based on adjacent traffic control devices. It is always important to coordinate with all appropriate parties during scoping to determine what model type is most appropriate to be used. Refer to MoDOT EPG 905.3.5.2.2 for more information on the model capacity types. The inscribed diameter is equal to the central island diameter plus the circulating road width times 2. This is a user-defined parameter that should be input based on field data and design plans. Per the NCHRP 672, the typical ranges include 45 to 90 feet for a mini roundabout, 90 to 180 feet for a single-lane roundabout, and 150 to 300 for a multi-lane roundabout. More information can be found in Table 905.3.5.2.2.3 of the MoDOT EPG. Environmental factor calibrates the SIDRA Standard Capacity Model to allow for less restricted, higher capacity and more restricted, lower capacity. The factor allows for the effect of different driver behaviors, driver aggressiveness and alertness affecting driver response times, and general characteristics of the roundabout environment in terms of roundabout design type, visibility, significant grades, operating speeds, size of light and heavy vehicles. Potential values range from 0.5 to 2.0. Typically, a range of 1.1 to 1.2 should be used. Generally, 1.1 would be used where drivers are familiar with roundabouts. Higher values, typically 1.2, would be used where drivers are less familiar with roundabouts. The model calibration factor is the corresponding factor to be used in the HCM capacity model. It is similar to the environmental factor, where increasing this factor will decrease the capacity. Refer to MoDOT EPG 905.3.5.2.2 and the SIDRA User's Guide provided with the software for more detailed information.
Extra bunching helps analyze the effect of upstream signals on the gap acceptance capacity of roundabouts. Bunching percentages range from 0% to 25%. Bunching is equal to 0% if the traffic signal is further than 2,600 feet away. Bunching is equal to 25% if the traffic signal is within 350 feet from the roundabout. Refer to MoDOT EPG 905.3.5.2.2 for more information. This EPG also summarizes the intermediate bunching percentages between 0% and 25%.
Bypass lanes can be added as an option in SIDRA. This can be a good option for improving the flow of the roundabout. However, be cognizant of the flow of vehicles through this bypass lane onto the exiting lane. Sometimes the operations of the bypass lane can be misleading. If there are any heavy volumes on the existing lane or heavy turning movement volumes associated with this bypass lane, then there could be an underrepresented issue with congestion. It is important for the analyst to provide extra scrutiny to the data associated with these movements and ensure no unrealistic results are being displayed. Now that we have discussed the capacity model type, we can move on to understanding the MOEs for a roundabout. The primary MOEs for a roundabout include degree of saturation, or volume to capacity ratio, delay, level of service, LOS, queuing, and stop rates. These MOEs are displayed in a SIDRA movement summary table, which is shown in the next section called Movement Summary Table. The degree of saturation is an MOE provided by SIDRA that certain other tools, such as VISM, cannot provide. This MOE can be very telling of how a roundabout's operations are performing. According to the NCHRP 672, VC provides a direct assessment of the sufficiency of a given design. Degree of saturation, or VC, is more fully elaborated upon in section 4.5.5 of the NCHRP 672.
VC is a comparison of demand at the roundabout entry to the capacity of the entry. When a degree of saturation exceeds a range of 0.85 to 0.90, roundabout operations enter a more unstable range, and roundabout conditions could deteriorate rapidly, particularly over short periods of time. This volume delay function graph displays how the effects of congestion rapidly increase after VC is greater than 0.85. In this graph, the x-axis is the VC ratio, and the y-axis is a congestion function. This red line shows where x, or VC, is equal to 0.85. For values where x is greater than or equal to 0.85, there is a rapid onset of congestion effects.
One of the major benefits of a roundabout is its positive impact on safety. Roundabouts typically reduce fatal and serious injury crashes by lowering approach speeds, providing more forgiving angles of crash impacts, reducing the potential conflict points from 32, a traditional four-leg intersection, to 8. This includes the virtual elimination of head-on and high-speed right-angle collisions. When considering multiple project intersection design concepts, the safety benefits of a potential roundabout should always be considered.
Now that we've overviewed the MOEs for a roundabout, we can discuss the movement summary table.
The movement summary table is typically used to document roundabout MOEs, especially the primary ones highlighted on this slide. The user should take a comprehensive approach to roundabout analysis and be sure to assess all primary MOEs as part of the big picture of roundabout operations. For instance, if a LOS is reported as a D or better while volume capacity or queue lengths reflect poor operations, then the intersection or lane group could be considered as having the equivalent of a failing LOS. Reminder, a degree of saturation of 0.85 VC or less is desired for each lane group. If the degree of saturation is greater than 0.85, then the analyst is encouraged to perform sensitivity analysis to determine the influence of volumes on roundabout delays and queues. Now, let's compare SIDRA to other traffic software tools. This is a high-level comparison of typical MOEs that are used based on the analysis tool. This table overviews traffic operations MOEs for the following analysis tools: HCS, SIDRA, Synchro, SimTraffic, and Vism. Note that SIDRA provides a comparable range of MOEs to various aspects of other tools. Now, let's overview common application situations where SIDRA is paired with other analysis tools, such as Synchro and Vism. SIDRA and Synchro can be used when a project encompasses an arterial roadway segment that is operating under capacity with multiple intersections. SIDRA can be used to analyze roundabouts. However, it is often used as a complementary tool to analyze roundabouts, including in a corridor with other intersections. This could occur when a project encompasses an arterial that includes a roundabout and one or more signalized or unsignalized non-roundabout intersections. In this scenario, SIDRA and Synchro may be adequate and micro-simulation may not be needed. Synchro would be used to analyze the signalized and unsignalized non-roundabout intersections of the arterial. SIDRA would be used to analyze the operations of the roundabout. Another potential analysis tool pairing includes SIDRA and Vism. In this scenario, Microsimulation would be scoped and identified as being needed. SIDRA would be used initially to provide aggregated analysis results of the operations of the roundabout. VISM would be used to analyze the roundabout and adjacent intersections and could include animation. For the roundabout, SIDRA results would be compared to VISM results. Reasons for this pairing could be the analysis of a roundabout with oversaturated traffic conditions to determine impacts to adjacent intersections, or when analyzing multi-lane roundabouts, especially if lane utilization is an issue or there is a large imbalance in turning movements. It is always important to coordinate with all appropriate parties during the scoping to determine the tools needed for analyzing roundabouts. Now, let's discuss key takeaways and additional resources. Key takeaways for this module include when to use SIDRA, typical SIDRA parameters to be aware of, typical MOEs for a roundabout, SIDRA comparison to other tools, and common application situations. Additional information can be found in MoDOT EPGs, on SIDRA's website, and the NCHRP Report 672, and in information provided by the FHWA report template.
Time to see what you know.
Question 1. What type of tool is SIDRA? A. Sketch planning. B. Travel demand model. C. Microscopic simulation model. Or D. Analytical deterministic. The correct answer is D. Analytical deterministic. Question 2. True or false? In the United States, SIDRA is typically used for roundabout analysis. The correct answer is true. In the United States, SIDRA is typically used for roundabout analysis. Question 3. How many potential conflict points does a roundabout have? A. 4, B. 8, C. 16, or D. 32? The correct answer is B. 8. Roundabouts have 8 potential conflict points. Question 4. What is considered a primary MOE for roundabout analysis? Is it A. Travel time, B. Degree of saturation, C. Reliability, or D. Time mean speed? The correct answer is B. Degree of saturation, VC. Remember, a degree of saturation of 0.85 VC or less is desired for each lane group. If the degree of saturation is greater than 0.85, then the analyst is encouraged to perform sensitivity analysis to determine the influence of volumes on roundabout delays and queues. Question 5. What analysis tool is commonly paired with SIDRA for the analysis of a corridor operating under capacity with multiple intersections, including roundabouts and other intersection types? Is it A. Synchro, B. HCS, C. SimTraffic, or D. IHSDM? The correct answer is A. Synchro. Thank you for participating in the TIA Guidance SIDRA module. MoDOT encourages you to view the other TIA Guidance Learning modules. If you have any questions, please reach out to MoDOT Central Office, Highway Safety and Traffic.